So this is an exercise related to covalent bonding and structure. In the first one, the table shows electronic structure of four atoms. Which two atoms combine to form covalent? We know covalent bond can form between the non-metals. When two or more non-metals join together, this will result in a formation of covalent bond. And non-metals will have, in the last shell, they will have 4 electrons, 5, 6, 7 or 8 electrons. So when we check element atom W is having 1 electron, so if it is having 1 electron means it will be a metal. Element X is having 4 electrons, so it will be a non-metal. Element Y is having 7 electrons, so it will be a non-metal. And element Z is having 8 electrons, so it is also a non-metal. But atoms which are having 8 electrons in the last shell, it means their shell is complete, so they don't react or they are unreactive or group 8 elements. So it means Z will not react at all, and W is a metal. So which two non-metal join together to form a covalent bond? So it will be between X and Y. So C will be the right answer for this. Because the covalent bond is formed between the non-metals. So first we identify from the electronic structure, we identify the non-metals, and Z is even a non-metal, but because it is having a complete shell, so it is unreactive or it does not react. In question 2, which statement describes the attractive force between the molecules or intermolecular force? So forces between the molecule, like example, you have oxygen molecule. So the force between the molecule is very weak. That's why the molecules, the substance which have a covalent bond and their molecules, they have a low melting and boiling point. So A and B cannot be an answer because that is totally wrong. They don't have a strong force. So either C can be answer or D. But what about statement D? Statement D is they are weak forces which hold the ions together. But in a molecule, in a covalent substance, we don't have ions. So that statement is wrong. That's why C is the right statement. In question 3, diamond is extremely hard and does not conduct electricity. For question 2, why C is the right answer? Number 1, the force of attraction between the molecule is weak. Because like example, there's you have a chlorine molecule which is Cl2 and there's another chlorine molecule, so they don't have bond with each other. That's why this force of attraction between the molecule is always weak. And that is also a reason that the covalent compounds have low melting and boiling point. So A and B are totally wrong because the molecules don't have strong force, they have weak force. So either C can be answer or D can be answer. But in a covalent substance, we don't have ions. In ionic compounds, we have ions and letters. In a covalent substance, we have simple molecules. So there are weak forces formed between the covalently bonded molecules. That's why C is the right statement which explains the force of attraction between the molecules. D, it's for ionic compounds, and ionic compounds have a strong force and they have ions. But for C, the covalent substance have molecules, simple covalent substance have molecules, and there's a weak force between the molecule. That's why they have a low melting and boiling point. In question 3, diamond is extremely hard and it does not conduct electricity. Which statement explain these properties? So this is related to macromolecule. It has a lattice of positive carbon ion and sea of electron. That's wrong because that is a structure of metal. It has delocalized electron and each carbon form 3 covalent bond. That's wrong because that is about graphite. It has no delocalized electron and each carbon form 4 covalent bond with carbon atom. That's true. That is a property of the diamond that each carbon is forming a 4 covalent bonds. And strong ionic bonds, diamond in diamond we have a carbon atom and non-metal with another non-metal atom does not form an ionic bond, they form a covalent bond. That's why D is also wrong. In question 4, diamond and graphite both forms of element carbon. Which row shows the number of carbon atom that each carbon atom is covalently bound? So in diamond it is having 4 bonds, but in graphite each carbon is forming 3 bonds and there is a 1 free electron. So in graphite there are 3 bonds, in diamond there are 4 bonds. That's why B will be the right statement. Which substance is a macromolecule or a giant molecule? So as we discussed, only 3 you have to learn as we discuss in the macromolecular topic: the diamond, graphite, and silicon 4 oxide. So these are the 3 macromolecules which you have to learn as an example. So that's why directly we'll mark C as the right answer. In question 6, metal P react with non-metal Q. Which process take place? So when metal react with non-metal, actually electron transfer from metal to the non-metal. And when metal will lose electron, metal will get a positive charge, and non-metal gains electron, non-metal will get a negative charge. And this attraction between the positive and negative ion, that is known as ionic bond. So the metal will lose electron, non-metal will gain electron, and it will form ions, and the attraction or type of a bonding is known as ionic bonding. So electron transfer from P to Q and the bond will be ionic. If any question you want me to repeat, I will repeat that at the same time, so you can just let me know once I move on. In question 7, this is a structure of ethanoic acid. Which diagram shows the arrangement of outer shell electrons in molecule of ethanoic acid? Look, it's easy to understand this, that each line represent a pair of electron or 2 electrons. When there is a single line, it means there is a pair of electron. When there are 2 lines, it means 2 pairs of electron, or their total will be 4 electrons between them. And if 3 lines are there, it means triple covalent bond, and it will have 6 electrons between them. So between carbon and hydrogen, there should be a pair of electron. So, and we can check according to the group number as well, that carbon belongs to group 4. So as the carbon belongs to group 4, it will share 4 electrons, and the total number of unshared will be 0. Whereas oxygen belongs to group 6, so it will share 2 electrons and total number of unshared will be 4. So A and B are wrong. Why A and B are wrong? You can see in A, oxygen does not have any unshared electron. That's why directly when I look at A, I found that it is wrong. When I check B, how many unshared electrons are there? 2, 4 and 5. So B is also wrong. B cannot be a right answer because it is having 5 unshared electrons. Now, either it can be C because you can check Oxygen is having 4 unshared electron, oxygen is having 4 unshared. But when you check hydrogen, because hydrogen is having only, it shared only 1 and unshared will be 0. So when you check here oxygen, each oxygen having 4 unshared, so either C can be answer or D. But what about hydrogen? When you check option D, hydrogen is having 1 unshared electron, but according to this rule, hydrogen should not have any unshared electron. So that's why D is also wrong. So which one is the right answer? C will be the right answer. So we can work out directly from counting the number of unshared electron. If that one is correct, then we will check the shared one. The structure of methanol is shown. Which diagram shows the correct arrangement? So again we will check hydrogen. It belongs to group 1. It will share 1 electron and unshared will be 0. Carbon belongs to group 4, so it will share 4, unshared will be 0. And oxygen belongs to group 6, so it will share 2 and unshared will be 4. So when we check A, oxygen does not have any unshared, so it cannot be A. When we check B, oxygen is having 4 unshared and hydrogen should not have any unshared, but hydrogen is having 1 unshared electron, so it cannot be B. When we check option D, oxygen is having 5 unshared electron, 1, 2, 3, 4, 5, but it should be 4, so that's D cannot be a right answer. So we are only left with option C, in which you can clearly see that oxygen is having 4 unshared electron, hydrogen and carbon does not have any unshared. So these type of diagrams are given. If you directly check the unshared, you can simply get the correct answer. In question 9, ethanol is a liquid at room temperature and boil at 78. So ethanol is having a low boiling point. Sodium chloride is solid at room temperature. Why sodium chloride or NaCl is solid? Because sodium is metal and chlorine is non-metal. So ethanol is basically a covalent compound because it contains carbon. This is a formula of ethanol, C2H5OH. It contains carbon, hydrogen and oxygen. Whereas sodium chloride, it contains metal and non-metal, so it will be ionic. And ionic bonds are stronger. The force of attraction between the ions is stronger as compared to force of attraction between the molecules, because molecules does not have charges. That is why their attraction is much weaker. So when we check the options, which statement about the bonding in ethanol and sodium chloride is not correct? Each molecule, each ethanol molecule is held together by weak covalent bond. There is no covalent bond between within the molecule. There is a covalent bond, but between the molecule there is no covalent bond. Like this is one molecule of ethanol. This is another molecule of ethanol, C2H5OH. So between the molecule there is attraction, but that is not the covalent bond. This is a weak attraction, but not refers to covalent bond. What is a covalent bond? The covalent bond is between the atoms, like the atoms in the structure, when they share electron, we call that bond as covalent. But between the molecule, we don't have this covalent bond. So that's why A is not the right statement. When we check statement B, ethanol molecules are held together by a weak attractive force. That's true, because it's a covalent substance. Covalent substance, like this is one molecule of ethanol and this one is another, C2H5OH. So these molecules have attraction, and this attraction is known as a weak attraction, but not refers to a covalent bond. Sodium ion and chloride ion are held together by strong attractive force. That's true, because sodium ion will be positive and chlorine will be negative and they will have a strong force. That's true. Sodium ion and chloride ion are held in a giant lattice. That's also true because sodium is positive, chlorine is negative, and it will be a giant structure, lot of ions in the structure. So we also call that as a giant lattice of ions. So statement D is also true. Next, the molecule of N2, C2H4, CO2 and CH3OH all have covalent bonds. These bonds consist of shared pair of electron. Which row give the total number of shared pair of electron in the molecule? So for this purpose, you have to draw the structure for each molecule to identify the number of shared pair. So first it is N2 nitrogen. Nitrogen, it belongs to group 5. So if it belongs to group 5, it will share 3 electron and unshared will be 2. So when we draw the structure of molecule of nitrogen, which is N2, so we draw first nitrogen and the second nitrogen. The shared electron we draw between them, so 3 shared electron by each. So 3 electrons shared from the nitrogen on the left hand side and 3 electrons shared from the nitrogen on the right hand side. And there will be 2 unshared electron, but they're only asking for total number of shared electron. We draw a circle and the unshared electron we draw on the atom. So how many shared electrons are there in N2? 1, 2, 3, 4, 5, 6. So there are 6 electrons and total number of shared pairs of electrons. So there are 3 pairs because 6 electron means 2 electron means 1 pair. So there are 3 pairs of electrons, but here in the option it is written 2. So it means it cannot be A. Then we check the second option, which is C2H4. So carbon belongs to group 4. As carbon belongs to group 4, it will share 4 electron and unshared will be 0. And for hydrogen, it will share 1 and unshared will be 0. So when we draw the structure of C2H4, the one which share, the maximum number should be there in the center. So 2 carbon atoms in the center and hydrogen will be around them. So as we know, carbon belongs to group 4, so it will share 4 and hydrogen will share 1. So if this hydrogen shares 1, carbon can share 1 from that side. Same thing, if this hydrogen, the surrounding hydrogen share 1, carbon can share 1 from that side. But the total number which carbon has to complete, the total number of electron, as it is C2H4, so I should draw 2 more hydrogens. So 1, 2. So if this hydrogen share 1, carbon will share 1, hydrogen share 1, carbon will share 1. But total number of electrons which the hydrogen share, that's 1, but total number of electron which each carbon should share, that is 4. But this carbon on the left hand side shared only 2 and the carbon on the right hand side also shared only 2. So remaining 2 electrons are there and that are shared between the 2 carbon atoms. So this is the structure of C2H4. Now to work out the number of pairs, so this is 1 pair, second pair, third pair, fourth pair, fifth pair, and sixth pair. So there are 6 pairs of electrons. So total number of electron pairs, that is 6. That's why B is the right answer for discussion. So in exam you have to draw the structure and then you have to work out the number of shared pair of electrons between the atoms. In question 11, two statements about silicon 4 oxides are given. Silicon 4 oxide, it's a macromolecular, a giant structure. It is hard substance, that is one, and it has a macromolecular structure with strong covalent bond. Covalent bonds are stronger, which is correct? Which statement is correct? So silicon 4 oxide is hard, that is true, and it is also having a macromolecular structure. So both statements are correct. And how statement 2 explains statement 1? Because if something is having a giant structure, as we discussed the physical properties, whenever something is having a giant structure, it will always be hard. So statement 2 explains statement 1 because it is having a macromolecular or a giant structure, that is why it is hard. So A is the right answer for this. Which dot and cross diagram shows the outer shell electron arrangement in a molecule of nitrogen? Molecule of nitrogen means N2. So nitrogen belongs to group 5. As it belongs to group 5, it will share 3 electrons and unshared will be 2. So each nitrogen should share 3 electrons. This is sharing only one, a pair is there, like one from each, so that's wrong. This one is sharing 1, 2, and 3. So they are sharing 3 electrons from each, and unshared will be 2. So that's why B is the right answer. Here you can see they're sharing 2 electrons from each nitrogen, sharing 2, 1, 2, and here each nitrogen is sharing 1. That's why B is the right answer for this. Which dot and cross diagram shows the outer electron arrangement of a molecule of carbon dioxide? So carbon dioxide, carbon, it belongs to group 4. When element belongs to group 4, it will share 4 electron and unshared will be 0. And oxygen, it belongs to group 6. As it belongs to group 6, it will share 2 electron and unshared will be 4. So you will check the unshared. A cannot be an answer because oxygen does not have any unshared. When you check B, oxygen is having 5 unshared, so that's also wrong. When you check D, oxygen is having 6 unshared, that's also wrong. So we are left with only C, which is a right statement that each oxygen is having 4 unshared electrons. So directly if you work out the unshared, you can find the number of shared one and you can find the right structure. Which compound is silicon 4 oxide? So what are the properties of silicon 4 oxide or the giant structure? That it is hard, number one. It does not conduct electricity. It does not conduct electricity even it is solid or molten. And it should have a high, because it's having a giant structure, macromolecular structure. So it should be a high melting point. So when we check the options, B is high melting point, C is high melting point, and D is also high melting point. But what about the second, electrical conductivity in solid? Because silicon 4 oxide does not conduct, so it should be no. And electrical conductivity in a melted form, silicon 4 oxide does not conduct even in a melted state. So what is the right answer? D will be the right answer. That a macromolecular structure have high melting point, but specifically silicon 4 oxide and diamond, they do not conduct electricity even they are solid or in a melted state. If it was an ionic compound, then it should have a high melting point. It does not conduct electricity in a solid, but it can conduct electricity in a molten. If it was an ionic compound, like the same question was there, which compound is sodium chloride? So if they ask which compound is sodium chloride, it should be high, so it can be B, C, or D, but it does not conduct electricity in solid and it conduct electricity in molten, then it will be B. But they're asking for silicon 4 oxide or for diamond, they do not conduct electricity in any state. Question 15. Which dot and cross diagram shows the outer shell electron arrangement in a molecule of carbon dioxide? So again, what you will do, the simple way to identify carbon as it belongs to group 4, it will share 4 electron and unshared will be 0. And oxygen, it belongs to group 6, so it will share 2 and unshared will be 4. So when we check the unshared one, the total number of unshared electron. So when you check this option A, these are what we draw in between, these are the shared one. Even if you check option B, 1, 2, 3, 4 and 5. So 5 unshared, so it cannot be B. Here oxygen is having 4 unshared, but when you check carbon, carbon is having 2 unshared electron, but according to this, carbon should not have any unshared electron, that's why it is not C. What about D? Oxygen is having 6 unshared electrons, but it should have only 4 unshared electrons, so it cannot be D. So what is the right answer? A is the right answer, in which oxygen is having 4 unshared and it is having 2 shared electron between the carbon and oxygen. And same thing, 4 unshared and 2 shared are there, which are drawn between the atoms. Which two molecules contain the same number of electrons? How to get the number of electrons? So for this you have to use a periodic table. Chlorine, when you check the periodic table, chlorine is 17, sulfur is 16, oxygen is 8, hydrogen is 1, and carbon is 6. These are the number of electrons present in each atom. Carbon contains 6 electrons, one carbon contains 6, chlorine contains 17 electrons, one hydrogen contains 1 electron, oxygen contains 8 electron, and sulfur contains 16 electrons. So when we find the total number of electrons, because they're asking which is having the same number of electron, so chlorine, which is Cl2, so one chlorine is having 17 electrons. So Cl2 means 2 chlorine. So one chlorine is having 17 electron, 2 chlorine will be 17 multiplied by 2. So a chlorine molecule will have 34 electrons. What about sulfur dioxide? Sulfur contains 16 electrons and one oxygen contains 8 electrons, multiplied by how many oxygen are there? 2. So 8 multiplied by 2, 16, and 16 plus 16, that's equal to 32. So it cannot be A. What about option B? When we check CH4, so carbon is 12, carbon is 6 electron, atomic mass is 12, number of electron are 6, plus hydrogen is having 1 electron multiplied by 4, so 4 plus 6, that's equal to 10 electrons. And in water, H2O, hydrogen is having 1 electron and there are 2 hydrogens, so total will be 2, plus oxygen is having 8 electrons, so 2 plus 8, that will make 10. So in CH4 and H2O, both have 10 electrons, that's why B is the right answer. So using a proton number or atomic number, you can work out their number of electrons. Potassium bromide and methanol are both compound. Their melting points are different. So potassium bromide, potassium is a metal and bromine is a non-metal. So when metal combined with non-metal, it will be ionic. And ionic compounds will have high melting point. Whereas methanol, it's a compound of the carbon, hydrogen and oxygen are there. So it will be a covalent compound. And covalent compound will have low melting or boiling point. So their melting points are different. Which row is correct? The options are on the next page. So which row is correct? If we check the substance with a high melting point, so it cannot be methanol, so A and B cannot be an answer. So either C can be answer or D can be answer. And because potassium bromide is an ionic compound, so ionic compound, the attractive force between the oppositely charged ions is greater than the forces between the molecule. Because in methanol, there will be molecules and potassium, like if I draw the structure for both, potassium bromide is an ionic compound. What does it mean? It will have a giant lattice of positive and negative ions. Positive potassium ion will be there and negative bromide ion. This will be the structure and it will have a strong force. That's why it will have high melting or boiling point. About the methanol, this is like the molecule of methanol. The structure is already given in the previous MCQ. So this is a simple structure of methanol. This is one molecule of methanol, which is having a sharing of electron. Then this will be another molecule of methanol. Within the molecule, these bonds are known as covalent bond. But between the molecule, there is attraction, but this is not known as a covalent bond. This is the weak attraction between the molecules, and that's why methanol will have a low boiling point or melting point, whereas potassium bromide will have a high melting point because it is having a strong force between the ions as compared to force between the molecules of methanol. So C is the right answer for this. Why it cannot be D? Because they mention the higher melting point will be potassium bromide, but they mention the attractive force between molecule is greater. But attractive force between the molecule is always weaker as compared to force between the oppositely charged ion. Like if I have a positive and negative charges, they have a strong force as compared to when I have molecule. Like if two molecules are there, they will have always have a weak force. But when I have ions charges, they always have a strong force of attraction. That's why C is the right answer. And question 18, the formula of ammonia is NH3. So it's NH3 nitrogen bonded with hydrogen. Which statement about a molecule of ammonia is correct? The bonding, because nitrogen is a non-metal, hydrogen is a non-metal. So when two non-metals are there, they cannot have an ionic bond. That's why it cannot be A. Nitrogen atom has a noble gas configuration. Whenever the covalent bond is formed, all the atoms have a noble gas configuration. What is the meaning of this term, noble gas configuration? It means they all have, when they form a bond, they all complete the shell. So when the atoms complete the shell, we use the statement they have a noble gas configuration. So when the bonding occurs, between nitrogen and hydrogen. Nitrogen share 3 electrons and hydrogen share 1 electron. So their shells are now complete. That's why they're forming a bond to complete their shells. So when the atoms completed their shell, we use the term that they have noble gas configuration. So statement B, they say nitrogen atom has a noble gas configuration, but hydrogen atom do not. That is wrong. Both atoms have a noble gas configuration. It means both atoms are stable or their shells are complete. What about statement C? Nitrogen atom share all of its electron. That's wrong because nitrogen belongs to group 5. So element belongs to group 5. It will share 3 electron and unshared will be 2. So that's why C is also wrong. There are 6 shared electron in the molecule. That's true. 1, 2, 3, 4 and 5, 6. That's why D is the right answer. What is the meaning of this statement? Nitrogen atom has a noble gas configuration. What is the meaning of this term noble gas configuration? It means it is stable. And whenever atoms form a bond with each other, they are stable. So because nitrogen is forming a bond with hydrogen, so nitrogen atom as well as hydrogen atoms all are stable. But in this statement, what they're saying nitrogen atom has noble gas configuration or nitrogen atoms are stable, but hydrogen atoms do not or they are not stable. That is the mean. But it is wrong because whenever the bond is formed, both atoms gain the stability or they become stable. How it is stable now? As you can see, hydrogen is having 1 electron in the first shell. So first shell maximum can have 2. And nitrogen having 5 electrons, so it needs 3 to be stable. How we know they are stable? If their shell is complete, they are stable. Like example, nitrogen share 3 electron, 1, 2 and 3. Hydrogen share 1 electron, 1, 1 and 1. And how many unshared electrons are there? For nitrogen, there are 2 unshared electrons for nitrogen. So nitrogen, how many electrons are there? Whenever a bond is formed, the atom becomes stable. So 1, 2, 3, 4, 5, 6 and 7, 8. So nitrogen is having 8 electron. So when atom is having 8 electron in the last shell, it is stable. What about hydrogen? Hydrogen is having 2 electron. So when atom is having 2 electron in the last shell, it also becomes stable. That's why statement B is not correct, because in statement B say nitrogen is stable but hydrogen is not stable. Is it clear? I'll share another link and continue this discussion of covalent bonding about this structure questions.